Okay guys, so now I'm creating one more lab video, and this lab video is for static routing load balancing. And in this static routing load balancing, we will be knowing about the default behavior of the load balancing, and after that we'll work on how we can make primary and secondary link with the help of floating a static route configuration, which is advanced static routing. And why I'm doing this lab, because while configuring the load balancing lab we got some errors. So now this video is only for the static load balancing, okay, and the floating route. So here we have 10.0/24 network. So we will be configuring IP address first, and then we'll enable static routing. So here I can explain you the lab first. We are using 4 computers, and after that we have router here. Okay, so we have router. You can say this is your own company edge router, and now your router is connected with ISP1. You are using 2 link and ISP2, and you have to reach to this is the internet address, which is 1.1.1.1, okay, which is the address of router 4 loopback, okay, 1. So here you can say I have changed the images here. So here you have router 1, this is your router 1, and this is your ISP1 is your router 2, ISP2 is your router 3, and this internet server is also your router, okay. So now we can start and take a console of all these devices. Okay, so PC1 address is so we are configuring the IP address on PC, which is connected to R1. Okay, so the IP address of PC is configured now. If you want, you can save it. Okay, now let's move to your R1, which is your company edge router. Okay, so this is the address of Ethernet 0x0, and this address will be used as the default gateway on all the client computers. Okay, so I have configured E0x0 and E0x1. Now I am configuring Ethernet E0x2. So after configuring IP address, if you want, you can save it, and after saving you can check. So IP interface brief, exclude unassigned. Okay, so IP address is configured on R1. Now come to your ISP router. So ISP has 2 interface, E0x1 and E0x0. So I'll come here E0x1 first, IP address. exit, do writes, and then do so IP interface brief exclude. Okay, so now IP is configured on ISP 1. Now come to ISP 2, interface E0 by 2, 13.2 will be the address, and the subnet mask will be 252, means /30 is there. Then come here, E0 by 1, 34.1 will be the address. Okay, so IP so IP is configured on ISP2 as well. Now come to your www, which is the internet router. Come here to configure the interface first. So it is E0 by 0, IP address is 24.2, and the subnet mask is /30. Now internet Ethernet E0 by 1, 34.2, okay. Then in loopback interface, so come here, interface loopback 1, IP address, loopback 1, you can say it's a separate network. So if you do not want to add any switch and PCs to show the LAN, so add a loopback. So loopback will indicate a separate network just for testing purpose. And then here you can check here, okay, done. Save the configuration. So as we have seen, we have configured IP address on all the devices. Now we are configuring the static route load balancing. So our concern area will be only this, because you are not responsible to configure ISP network, right? So how ISP is configuring the network, that is not your part, but you have to take care about your own router. Okay, so let's come here from this way. Okay, from your router, come here from your router, you have to then you have to write, first of all you have to check here, so IP route. So now you do not have the internet routes, so you need those internet routes in your system. So your PCs can ping to 1.1.1.1. So right now they are not pinging because destination host is unreachable. And why they are not pinging? Because you do not have routes. Okay, so how you will get routes? You will get routes from ISP. So you have to write here IP route 12.1.1.1.1. 255.255. This is the network and you are my gateway. That's it. So you can write, because you have two gateways, ISP1 address and now this is the ISP2 address. So your work is done. Now see how ISP is configuring it. ISP1 will configure IP route 12.1.1.1 and then again IP route 24.2. is ISP1 configuration. Now ISP2 configuration. IP route IP route 13.1 and second is IP route that is 34.2. ISP1 is okay, correct, okay. ISP2 is also correct. Now come here to www. This www.conft, here he will say only IP route one 192.168.10.0 and 24.1 is his own gateway, and 34 is also his own gateway, and then again IP route. Let's check if with this they will start communicating or not. Okay, so now here they are communicating, because if you will come here to router 1, so IP route, so router 1 said that I want to reach to 1, I have two gateway 13 and 12. ISP said okay, I will help you to communicate. If you check the so IP route, ISP said that okay, I'll make you reachable. Okay, so if you come here R1 routing table, R1 said that I want to communicate to 1, and who is responsible for communication? ISP. So ISP said that I know 1 and let me add you as a statically, so you can communicate via me. ISP2 is also saying the same thing. Okay, that okay, I know 1, which is because it is the internet server, let me add you as statically so you can easily communicate. And here you don't need to configure many things, just say that okay, because your request is coming from 10 network, so you don't need to add 12 and 13 because that is not your part, because they are the links, okay, point to point links. So here you have to add only, if you check here, so IP route, okay, so here you have to add only 10 networks. So when your PC is trying to communicate to 1, they are easily communicating, and once they are easily communicating, what you can do, you can, if you are tracing here, okay, trace 1.1.1.1, so you can see here first packet is going there, okay, and if PC2, again if PC2 is trace 1.1.1, so his packet is also going by this 12. Let's try here, all one is going via 1. Okay, what we can do, let's add one more address here. Loopback 2.2.2.2/32. Now come here to this conft interface loopback to IP address. Okay, here the configuration is done. Now come here to ISP1, you have to add a route for this network also. .2.2.2.2. Come here to ISP2, conft, add a route for this network also. Okay, now if you'll come here on PC1, now ping to 2.2.2.2. Why they are not pinging? Because if you come here R1, you have to add the routes for this also. So come here, add a route for 2 also, 2.2. Okay, so after adding routes, if you check your route, so you can see here you have the load balancing. See, you have 2 paths to reach 2 and 2 paths to reach 1 network. Now come here, let's try now. See, now they are communicating, and now let's trace how they are. Trace. Two. Okay, see here. Now PC1, when PC1 is trying to communicate to 1, he's passing via 12, and when he wants to communicate to 2, he's passing via 13. So you can see here they are doing load balancing, right? So once they are doing load balancing, right, now, so you can say that, okay, see how this load balancing is working. But the problem, one problem will come, and that problem is, this is not normal load balancing what it's supposed to work like. Okay, but after this load balancing, you can say that, okay, here I have Mbps connection. So here you have 10 Mbps connection, and here you have 5 Mbps connection. Okay, now you want to say that, no, I want to make this link as a primary and this link as a secondary. But right now, if you can see here, your both links are used, means your both ISPs are used as a primary. So one packet is transferring from ISP1, and one packet is transferring from ISP2. So here you will say, no, I want to make it as a primary and secondary. So I want to make this 10 Mbps as a primary and 5 Mbps as a secondary. So if primary will fail, then automatically my data should pass via secondary. So you have to come here, that is advanced static route, or which is known as a floating static route, what we have already discussed. So say very simple, you have to come here first. You have to say that, okay, first of all you have to remove the routes which is there. So how you will remove the routes? So run section IP route. So all the routes will come here what is configured. So first you copy, open in notepad, paste it here, and then first you write no, remove all the routes first. Okay, then here come here conf t and right click, so all will be pasted. So all the routes is removed. If you want to verify, so IP route, see, verify, no routes towards 1 and 2. Now you have to come here, you have to create a new. So you want to say that, okay, even in this also you want to make, so you can make it that, okay, for one network, right, or whatever network. So one network you want to make 12.111 as a primary, so make 1. Okay, and for this, so make it 2 secondary. So a small means lowest administrative value is the preferred, and the highest administrative value is the second one. Okay, so this is the administrative distance what we are, so we are changing the administrative distance. So earlier the normal default static route is 1, so we are changing to 2. So 1 is primary and this is secondary. For this also For 2 also, if you want to say no, for 2 I want 12 as a secondary and 13 as a primary. So you can copy this. Now you can come here to R1, conf t, right click, enter, then you check here, so IP route. So you can see here for 1 the 12 is primary, and for 2 13 is primary. So if you come here, if you are ping 1, fine, ping 2, fine, but if you trace, so 1 will pass via 12 and 2 will pass via 13. You will see this. So trace, 1 is always passing from this and 2 will always pass from 13. If you will come here to PC, this also trace 2.2.2.2, see, always via 13. And if you if any problem will come, that okay, maybe this link will go down, this ISP link, so come here to router 1, conf t, then interface E0 by 1 is shut, is down. Then if you'll come to PC1, first you have to check whether you are pinging or not. Okay, still you are pinging, the link is down, but still you are pinging. And if you will come for 2, still pinging is running. And if you will come now, one more option, that okay, let's trace for 1. So see, trace for 1 is 13 now, and earlier when the link was running, see, for 1 trace was for 12, and let's trace for 2. 2 is also 13. Why? Because you can see that 2 was already 13 and 13 link is up, so no problem. Okay, so you can see here that for 12 it was primary, but when the link goes down, now it automatically for 1 network is 13 now. And if you check the IP route, see here, okay, the link is down, so it is coming here. And when the link will come automatically up, if you say here conf t interface E0 by 1, no shut, and when the link is up, and if you're checking so IP route, okay, see here, it's changed. Okay, see here, when the link was down it was 13, but when the link came up, automatically it changed to 12. So this is your static routing load balancing plus static routing floating route. Okay, so how you are changing. Okay, configuration is very easy. What I did here, from R1 I made a static route, okay, towards 1 and 2. Okay, I did not add it 24 and 34. Okay, ISP made a static routes towards 10 network. ISP2 also made a static routes towards 10 network, and this internet server made a static routes towards 10 networks. That's it. ISP1 made a static routes toward 1 and 2. Okay, so if you want to check the configuration of R1, so IP route, so run, I should tell you, so run, see, this is the R1 configuration. Okay, and if you come to ISP, so run section IP route, if here also you can check in a correct, so run IP route. So this is R1 configuration. ISP configuration is C towards 1, 2 and 192.168.10.0. ISP2, so run section IP route. Okay, and ww, if you check this, so run section IP route. Okay, so this is the configuration, and see how they are doing load balancing as well as floating is also working.